In this video, what I'm going to do is demonstrate some of the various plotting and graphing that you can do in SpaceTime. So let's start with just a normal function plot. So I have a function, let's say sine of x. Now if I just hit enter, it evaluates the expression. But if I use x as a variable and I do an apple enter, then it auto detects the independent variable x, and then it just assumes y is equal to sine of x and it plots it like so. And so a slight variation on this, I want to focus on this video just on two-dimensional plots, but just to show you how easy it is with 3D plots, if I do sine of x plus y, x and y have very special sort of significance. You can't try doing this with sine of say a and b. It's got to be x and y. If we do an apple enter here, it auto detects that we've got a two independent variables, so a 3D function plot. All right. So just to kind of give you an idea that x and y do have very specific roles, is if I try to do sine of y, if I try to plot that, you might say, well, that's just a function of one variable. But what SpaceTime is going to do is it's going to say, oh, this is a function of both x and y, and it's going to plot it as such. So again, x has a very special role, as does x and y, as does this time variable t. So just to show the time variable t real quick, it increments at each frame. So the value of t is right there, and it does at increments. But we're going to focus on 2D plots. So where are all the plots listed? Well, if you go to entry and click 2D, then you've got all of these different options here. You could also go into the catalog and do just type out plot, and it lists all the different kind of plots that you can do. And so we even have a Julia plot, a fractal plot, etc. So one of the cool things is the shortcuts that are involved. So for instance, this polar plot, polar is usually r equals some function of theta. And so if you do a apple shift t, you get the theta symbol. So if we try to do an apple enter with just theta, SpaceTime auto detects that we want to plot r as a function of theta. Okay, so similarly, I showed this to a friend of mine once and he thought it was pretty cool. Z squared plus c. Again, these are common sort of ways to work with these expressions. This is the Mandelbrot set, or Mandelbrot, and SpaceTime auto detects that, oh, you want to do an apple enter, so it says, okay, well, z and c are the standard variables used, so I'll assume it's a fractal plot. So what's also kind of cool is you can change this to z cubed, and you get something slightly different as well. And if we zoom in, we can. Okay, so fractals are kind of fun to play around with. And then there's different options as well. 1, 2, 3. Okay. So that's fractals. So you can also use these functions as well, but just so you know, there are some shortcuts that are available. So for instance, let's do a parametric plot. What I could do is write it out, or I could click on this guy here, or I could do entry parametric. So you could first write it out to do, say, cosine of t, sine of t, and t is going to go from 0 to 2, and then if I do apple shift p, I get pi, and I get a circle, just like I would expect. And let's change this to a 2 and make the sine of say t over 2. Let's see what that does. And that gives us that right there. So, okay, you do slight variations of this and you don't get a circle anymore. So another way to get a parametric plot would be to click on this and it fills in for you, and then you can fill in the details. The third method is to click entry and then click parametric. And now it fills it in for you, and it's as a function of u, this variable u. And so I can type x is, let's try cosine of u plus u, and y will be sine of u. And let's just see what that does. And so we get the following plot. And so you can play around with number of points. So if I change this to 10 points, you get a coarser looking graph. I can change the window by clicking here, and I can change the range that u goes. So most of this is pretty self-explanatory. It's just a matter of seeing it once, and then it makes sense. So let's see, there's contour plots as well. So the contour plots is when you want to solve an equation like sine of x equals 1/2. Something like this. So if I do this, if I do a Apple Enter, what it does is it looks at points in XY space, and it says where is, so we're doing the positive, negative, and then lines, exactly. So now what it's doing is it's trying to figure out, okay, where does sine of x equal 1/2? And so we've got this right here. So it's a function of, usually you do both the x and y. So if I do sine of x plus y, I get perhaps a little more familiar or a little more two-dimensional kind of image. But it's the same thing in principle, which is for each coordinate x and y, you look at sine of x plus y and you say, all right, is this equal to 1/2, bigger than 1/2, less than 1/2, etc. And so you have these what are called contour lines, which show the places where you have this equality satisfied. So that's contour plot. Image plot, so we did fractal plot. Image plot is really nice. It's particularly useful for plotting matrices. So let me define a matrix A, say it's 10 by 10, and let me loop through it. And let's assign values according to, I think this is what's called the Hilbert matrix. So you just do 1 over I plus j, and end, and then let's just return the value of A to make sure we did everything right. Okay, so yeah, that's about right. So we have a matrix that looks like this, and then maybe we want to kind of visualize, you know, we can see this pattern here. Let's try to visualize it. So okay, cut to bad editing. So we have this matrix A that we've just defined, and now we're going to try to visualize it. And so the command we're going to use is image plot of A. We just got to hit enter, and then we get an image. And so what SpaceTime is doing is it's interpreting each one of these values as a grayscale image. Okay, so they've got to be between 0 and 1, and 1 is going to be white, 0 is going to be black. So here, to get a more fuller contrast, we should either divide by the maximum, or just, in this case, we know that it's 2. So if we just multiply by 2, we'll get sort of 1 as our max value, and then it tapers down. So that's how you would visualize a matrix. And perhaps the next natural question is, well, can I do this with RGB values? You know, a list of 3 matrices to give RGB values? And the answer is yes. Yeah, we can. So we've defined A to be like this. Let's define B similarly. So we'll just, let's do the absolute value of sine of this. Right? We want to make sure that our values are positive, or at least non-negative. So getting the absolute value will do that. So if we do B, we get a list with some floating point values between 0 and 1. Okay, and let's do it one more time with a matrix we'll call C. And let's see, what should we do? Well, let's just do cosine, absolute value of cosine. Okay, we get another set of values. So now if we do an image plot of the list consisting of A, B, and C. Now it's very important that these lists are all the same dimension. All right, which ours are. It's 10 by 10. And then if we hit enter, we get a color plot. That's kind of neat. So you can kind of see in kind of one direction here, it's kind of diminishing, but you get this really nice kind of sinusoidal pattern out of it, which you might expect. So, no, I think this is kind of cool. So I like using the image plot a lot. Another thing that you can use is a command called draw and draw window. These are in the manual. I can't really work with them off the top of my head, but maybe I'll make another video on this. But so these are the first major ones, I guess. Julia plot is similar to fractal plot, and then list plot, I've done that in another. Multiplot allows you to plot multiple plots in the same window. So if I want to do a multiplot of, so let's do a plot of sine of x, and then let's do a parametric plot of cosine of t, sine of t, t going from 0 to 2, apple shift p gets me a pi. If I do enter, then I get a multiplot. In other words, I'm able to mix and match, or just mix a plot and a parametric plot and plot them at the same time, essentially. So that is that. So then there's vector plot is the last major. So regression plot I went over in another video. Vector plot is the last major one that there's been some feedback about this plot as well. So basically this is determining sort of the slope at each point x and y in the coordinate axes. So you take this point here, the x and y values, the slope of this arrow is going to be given in the left-right direction by x, so it's facing sort of the right direction, and then in the direction up-down is determined by y. So because it's a negative y, we have that this arrow is pointing down and to the right, okay? And it's pointing to the right because it's a positive x value. This is one example. There's a way to plot differential equations on their slope field. It's just a simple formula. It's posted on the forums. I can't remember it off the top of my head, but basically this is how you would do a vector plot, things like this. Or again, you can always go to this entry button and then pick, say, polar, and then you have theta all lined up with the number of points, etc. And so I can do an expression like cosine of apple shift t, get a theta, hit enter, and I get a circle. Okay, so that's the basics for two-dimensional plotting.